Welcome back to another part in the MVVM Jetpack Compose course for beginners. And in this part, we're going to continue with the development of the recipe app that uses a recipe API. And we're going to integrate the next kind of part, which is pagination. So every app that displays a list of data should pretty much always use pagination, unless the list is short, less than, 100 items. I can't think of any reason why you wouldn't use pagination if you had any possibility of querying more than 100 items from your API. So if you don't know what pagination is, let me actually go to the documentation and I'll explain what pagination is and why we need to use it, just for those who don't have any idea what this thing is. So if we go to foodtofork.ca, which is the website that we are getting the data from. I built this website, by the way. If you go to it, there's pretty much nothing here. There's just, some documentation that describes how this API works. So there's two endpoints, searching for recipes and then finding a recipe by a particular ID. The only one that we currently have in the project is getting or searching for recipes. So this is an example of what the URL could look like if you're searching for recipes. So notice this little page parameter here. So this says page equals 2. Now let's go to Postman and do some examples using this request. So if we go to Postman, we have that URL up here. So the same thing from the documentation. We have page equals 1 and query equals empty. So if I press send, this is going to search for any recipe from the entire API. So notice that I'm using page equals 1 here. If I scroll down to the response from the server, hold on, let me scroll down. It doesn't look like, so it looks like that's as far as I can scroll down for you guys. So that's not a very good view, but I'll do my best to explain what's happening. So what we got here is we have a JSON object, and inside that JSON object is a parameter named results. Results is a list of JSON objects. So if we look here, this is like object number 1 right there. Then you would have object number 2 right there, and so on and so on. So if I scroll all the way to the bottom, the last object in this list is the 30th entry. So there's only 30 results from this one query. Well, we know obviously there isn't 30 results in the API. There's actually thousands of recipes on the API. So that's what pagination does. It breaks up the results from the API into pages. So here, notice it says 3016. That means there's 3016 recipes on the API, but I'm only showing 30 of them. So how do I get the rest? Well, that's what you use the page for. So if I go to page number 2 and press send, that then gets the next 30 results from the API. So inside of results here, I'm still getting 30. Like if I scroll all the way down to the bottom, there's still only 30 results here, but it's the next 30. In page equals 1, we got the first 30. Now we're getting the next 30. So if I go to page equals 3, I get the next 30 after that. So this would be like items 60 to 90. So for those of you who don't know, who don't have a lot of experience with software, this is generally how all APIs work. There's always some kind of a pagination system because you don't want to query, a massive list of data. You want to be as efficient as possible. Chances are when any kind of app or website or anything is, requesting data from the API, they don't want all 3,000 of them. They only want 10, 20, 30, maybe 40 at a time, because the user can't just look through, 3,000 recipes. They're probably going to look through 60 at the most or something. So breaking it up into chunks is just the most effective way to do that, or I guess the most efficient way to do that. So what does that mean for our project? Well, for our project in our recipe app that we're building that interacts with that API, we want to query the first 30 recipes. Then when the user scrolls down to the bottom of that 30 recipes, then it would get the next page of results and append those to the list. That's the most efficient, because if we tried to append, 1,000 recipes to our list in our app, the app would most definitely become very, very slow, and that would be a very poor user experience. So 30 at a time, scroll to the bottom, get the next 30, and so on and so on. But one last thing before we start writing code, I forgot I should probably mention this because I know some of you are definitely thinking about this. You're probably thinking, Mitch, why don't you use these paging libraries that exist and they handle the pagination for you? Well, I think paging library version number 3 is out right now. And I have to say that I personally have not tried that, but I've tried paging 1 and I've tried paging 2. And they are not very good. More specifically, if I'm remembering this correctly, when I tried paging number 1 and paging number 2, probably, at least a year ago, the reason I decided not to use it is because it wasn't able to handle multiple data sources. So typically, like in a use case, you're going to have a caching component and a network component. You get the data from the network, you cache it, and then you view the cache whilst doing that. Well, for whatever reason, I can't remember the specifics. I tried it and it didn't do that very well. And I also found it pretty complicated. I thought that building my own pagination system was simpler and it got done I was able to design it to fit my needs. So again, I haven't tried paging 3. Maybe it's better, maybe it's easier, maybe it's less complex, maybe it can handle multiple data sources. I don't know. I haven't tried it yet, but I'm going to show you how to build your own custom system in this video, and that's what I do generally. It's not complicated, so I think you'll have no issues with this. Okay, let's go into our view model. So go into recipe list view model. Now, the first thing here is we're going to define a constant that defines the size of the pagination, or the size of the queries that come from the API. So constant value, I'll do page underscore size and set that equal to 30. So recall from the API documentation, I mentioned earlier that there was a page size of 30, and you can see that from the documentation here. It says page size equals 30. So we want to make sure that we match up with the API that we are querying. And in our case, the page size is 30. Now let's create a new value inside of our view model to track the page number. So value page equals mutable state of, and just set that equal to 1. So that's obviously the starting value, page number 1, unless we do a query and go to the next page, which we'll look at shortly. Now we also want to track the scroll position. So I'm going to say recipe list scroll position and set that equal to 0. Technically in this video, this is not going to be doing anything, but I believe not in the next video, but the one after that, we're going to be working on restoring the state after process death. And this is going to be very important when we do that. I probably should have just included it then, but let's just keep track of it now. It's really not a big deal. So this will be used later. Just kind of keep that in mind. Now let's build a function for incrementing our page number. So scroll down below the new search function. I like to keep my sort of quote unquote use case functions at the top of the view model, and then all of the other kind of utility functions go down below. So that's why I'm putting it down below here. So we'll do private function increment page number, or increment, we can just say increment page, doesn't really matter, there's only one of these. So page.value equals page.value plus 1, pretty straightforward for that function. Now I want a function for keeping track of that scroll position. So function on change recipe scroll position, it will take an integer called position as input, it will return nothing. So now I want to do recipe list scroll position and just set that equal to position. I don't think, this should not be a value, that should be a var. Although maybe it can be private. Let's make that private. Also notice I forgot to mention that we're not using mutable state of for the recipe list scroll position because it's not something that we are observing. It's not something that we have to react to when it changes. It's just something that we are keeping track of. Now we're going to build a function for appending new recipes after the pagination or the new page request is complete. So I'll write some comments here that just says append new recipes to the current list of recipes. So we'll do private function append recipes. It will take a new list or an additional, list of recipes as input. And then I'll scroll down here to give you guys a better view. So first, let's get the current list. So value current equals array list this.recipes.value. So I'm getting that from the mutable state object up here, this list of recipes. Getting that and creating an array list out of that. Now, the reason I created an array list is because I want to be able to call add all, because I'm adding all of those new recipes. This needs an S on it, so that it's plural. And now once I have that updated list, now I want to do this.recipes.value equals current. So just getting the current recipes, appending the new recipes, and then setting that list to that mutable state object that holds the list of recipes. Now let's build the function that actually gets that next page of results from the API. So currently we have kind of quote unquote one use case that's inside of the view model, one thing that kind of takes action and we see those results on the screen. So now we need to build our second one. So come down below new search and just do a function, call it next page. And we'll do view model scope like we did in the other sort of quote unquote use case. Now the first kind of check here is we want to prevent duplicate events due to recompose happening too quickly. So this is not obvious right away, but I'll talk more about that when we actually get into recipe list fragment. But essentially the thing that we need to be careful for here is if we're scrolling and it gets to the bottom of the list, immediately as soon as it tries to get that next page of results, we need to make sure it doesn't keep trying. Because if it gets down to the bottom page and our trigger is when it gets to the bottom page, get the next page. Unless we have some kind of a restriction happening or some kind of a lock, like a quote unquote a lock, it's going to keep it'll get to the bottom of the list and go next page, really, really fast because of the recomposition. So we need some kind of a check or some kind of a lock that says start getting the next page. if there is a query in progress, don't keep trying to get the next page, because otherwise you're going to get, I don't know, 10, 20, 30, who knows, pages of results just from scrolling to the bottom. So let's continue on here. So we'll add an if check here saying if we'll do another set of brackets, if the recipe list scroll position, oh, we actually are using it in here. I lied. This is used to restore the state, but we actually are using it inside of our check here. So is greater than or equal to the page.value times the page underscore size. So right away, when we, try to get the next page, what we want to do is we want to go loading.value. First of all, just set that equal to true so we see the progress bar. And then we want to increment our page. So this check here is going to say, okay, if this current scroll position plus 1 is greater than or equal to the current page times the page size, then we can get the next page of results. If this is not true, then we will not be able to get the next page of results. So I didn't really plan this out, but I realized this logic is a little complicated, so I better do some kind of a diagram. So suppose we have a list of 30 recipes showing in here. So here's our app, and then we have 30 recipes, and here we would have, page equals 1. So suppose we scrolled all the way to the bottom. In that case, right away, what we would want is page would then equal to, we would get the next page of results. So then we'd be showing 60 results here. So while the page is at the bottom, technically just before, there's like a brief second or a brief few milliseconds probably before the list is updated with the new 60. So technically there's still like 30 in here. There's a few seconds when we scroll to the bottom that this is true, right? There's still 30 pages too, but we don't have 60 results. This is just the nature of software because everything moves so quickly. It's not going to have time there's time in between querying the API and then getting it into the actual list. So what could happen in those few milliseconds before this sort of transition is our function could get called any number of times. It could get called 10 times. And in that case, we'd see like, a huge number of list results appended, which we don't want. So as soon as this page is incremented, we essentially want to lock this so that it can't keep querying more results. That's what we're trying to do here. So here our logic here says recipe list scroll position is greater than or equal to page value times page size. So what does that look like in our diagram? So immediately in those few milliseconds when the page is incremented and there's still only 30 list results, what does that mean? That means page dot value. So the value that's in the view model is going to equal to our page size is always the same. So page underscore size, that's always going to be 30. So then this multiplied by this equals 60. So then taking a look back at our logic here, we have a recipe list scroll position. So at the time when we're scrolling down to the bottom here, what is the recipe list scroll position? So I'll just write, scroll position. What is the scroll position? The scroll position would be 30. So the logic here prevents us from getting more results because that would mean that we would have 31. So recipe list scroll position plus 1 is 31. If that is greater than page value times page size, which would not be true because that would be 60. So we kind of lock our next page function as soon as we increment the page number here. So as soon as this is incremented, this will no longer be able to be true until the data is actually appended to the list, in which case it's fine. That means we can get the next page of results. So hopefully that explains things for you, kind of explains this logic a little bit because I don't think this is easy to see. Essentially, it's a lock, right? Like as soon as we increment the page, we want to make sure that this doesn't happen. Hopefully if I remember when we get to the testing part of this video, like at the end, I'll comment this out and I'll show you the problems that it creates if you don't do this. Now I'm just going to write a log for debugging just to help you guys. I think this is a good place to put a log if you are running into problems. I'll say triggered and let's just do page.value. That way you can see like every time this function is triggered and also what the page is. Now I want to delay, we'll just delay 1000 milliseconds so we can actually see the loading. Because this API is really quick, you won't see any loading unless you do some kind of like a fake delay. So maybe I'll write a comment here actually just to show Pagination API is fast. Now we want to do if page.value is greater than 1, value result equals repository dot search, open this up, do token equals the token that's being injected to the view model, page equals page.value, query equals the query.value. And that's our result. So at that point, let's do another log for debugging just to kind of show you guys, what's going on. I can just print out that result and then we want to append that result to our list. So I want to say append recipes and append that result. Then at the end of the day, when this is all finished, then we want to call loading.value and set that equal to false to make sure that we hide that progress bar. So the reason I'm doing, page.value is greater than 1 here is because I don't want this to accidentally be called right when the app launches, when we're getting that first list of results, because that's going to be done by the new search function inside of init here. So for some reason, because of our trigger inside of the fragment, this gets called. This will prevent, a duplicate list getting added to our list. So now that we've added kind of a whole bunch of new stuff to our view model, we need to update our reset search state function. So this is called every time there's like a new search that's being executed. Well, because we have pagination now, we have new parameters that need to get reset. Like the page value needs to get reset to 1, and we need to call on change recipe scroll position, and also make sure to reset that to 0. So whenever a new search is done, we need to make sure we reset those parameters. Okay, we're done in the view model. Now let's go into recipe list fragment and let's update this and work on the pagination. So we need to add a new mutable state object here that we're going to be observing. That's going to be the page. So value page equals viewModel.page.value. Now scroll down to wherever our lazy column is. So scrolling down inside of the box, and here's our lazy column. So here we want to check if it's loading, and also if the recipes are empty. So recipes are empty, then we show the shimmer animation, because whenever there's pagination, we don't want to show the shimmer. We only want to show the shimmer when there's a brand new search being done. So that's how we can check. We can just say if the recipes are empty, then we show our shimmering animation. Now inside of the lazy column, we need to do a couple things. Number one is we need to keep track of that scroll position. So view model on change recipe scroll position, and then just pass that index. So that's why we decided to use the items indexed function inside the lazy column, because we're keeping track of whatever scroll position we're at. Now I want to do a check. I want to check, this is the check that I was talking about, where we're going to make sure that, the trigger for the pagination, when we scroll down to the bottom of the list, how do we detect that? So if index plus 1, if that is greater than or equal to the page times the page size, and we're not loading. So if basically we're checking to see the same kind of thing that we did inside of the view model here, essentially. So remember this sort of check that we did here. We're checking, instead of the scroll position, we have the index, and we're making sure that it's a valid time to request the next page. So if the index plus 1 is greater than or equal to the page times the page size, and then an additional check that says, and we are not currently loading. So this is like an additional check just to make sure, because if something is happening, if there's already a search that's being done, this Boolean will be true. So we're just kind of adding that additional check to make sure that we don't get duplicate entries, or duplicate requests, I guess that's a better way to put it. So now do viewModel.next page. So that should be it. So let's run this, and then we'll come back, like I said, and I'll comment this logic out, and we'll talk about this a little bit more, because I think that's kind of a little bit confusing probably. So running that, and now let's take a look. So as you noticed, I'm running this on a real device. I'm running it on a real device because scrolling on the emulator just takes too long. If I use my real device, it just works way better. So let's just check pagination by scrolling down to the bottom first. So if I scroll down, notice there's that progress bar. That means it's getting the next page of results. And now notice I can scroll further. So I have 60 entries now in here. And if I scroll down further, after the next 30, you'll see that loading again. Okay, it's trying to get the next page. And then there you go, I get the next 30. So that works good. Now let's try selecting a category. So I'm going to select chicken up here. And there's the loading. Let's scroll down to the bottom. It should get to the 30th entry and then show that it's loading more. Yes, getting the next page. And then you get the next page. I can scroll down again. Going to get the next page. Then now we have 90 recipes showing. And you could keep doing this as long as the recipes exist on the API. So now what happens if I come and I comment out this logic? So let's comment out this if statement, and let's see how this works. I guess the trigger should be fine. Yeah, we'll leave that and just see kind of what this looks like. I think it's gonna behave like it shouldn't. Okay, so here I have the log open. Now I'm going to scroll. So I'm going to scroll to the pagination. Now look what happens. So there you can see, if I ignore all of the list items that were printed, notice right here. So I only scrolled to the second page, but it got called twice. It said triggered getting page number 2 and getting page number 3. So that's this log right here. that's being called. So it's being called twice. And that's what I mean by like when you scroll to the bottom, the software works so quickly, like it works in milliseconds and nanoseconds. When as soon as it gets to the bottom, boom, it's going to trigger multiple times. So we need to add some kind of a locking mechanism, and that's what this does. So I'll comment this back in, and now we have like an additional check that says, okay, if something is already in progress, aka when our page is like already incremented and the scroll position hasn't changed, then we shouldn't be getting the next page of results. That prevents duplicate pages when we scroll to the bottom. So that's gonna be it for this video. As you saw, pagination, building a custom pagination system is no big deal. You don't need to use the paging libraries. In my opinion, they overcomplicate things. They build walls where there shouldn't be walls. Building a pagination system is not difficult. You just need to track the page number, increment the page number when you get to the bottom of the list, and make sure that you're not querying multiple pages. Like you need some kind of a locking mechanism. So just like we did, if you increment the page number and then just look and see, compare the scroll position with the page number times the page size, make sure that it's not greater than that, and boom, there you go. You have a nice locking mechanism. Next, we're going to talk a little bit about this thing called unidirectional data flow and state events. And I know some of you are thinking, but Mitch, wait, this is an MVVM course, not an MVI course. I know, we're just going to get kind of a little taste of MVI, and I'll show you kind of why I think it is a superior architecture. So I'll see you guys in that next video. Do not forget your engagement. You've been doing a good job. Don't stop now. Engage. Engage, engage, engage. Down below, engage. I'll see you in the next video. Hey, what are you still doing here? The video's over. Well, since you're still here, I guess I'll show you the best Android courses that exist on the planet. I got all kinds of high quality courses. If you scroll on down on the homepage, there's the Jetpack Compose one that you're watching right now. There's that course. We have MVI architecture, if you've ever been curious about that. We have my classic powerful Android apps with Jetpack architecture. This shows you everything from, well, the focus on this one is pretty much database caching. We get data from a real API, we cache it, we basically design an app to work when there's no network connection. That is what this project is all about. We have some UI testing, another UI testing, HILT, which we actually went over in this course. We got clean architecture. This one's probably the best. This is definitely the best course on my website. If you are a professional or you are looking to get into the industry, the skills that you learn in this course are absolutely fundamental. This will give you a big edge in any job environment, whether you're applying or you're already at a job and you want to just improve your skills. This is a really, really, really high quality course. It's hard. Your brain might explode while watching it, but you will learn a lot. You'll learn a lot of really, really fundamental skills. You know, anything from getting data from the network, caching data, designing different layers, abstracting out the different layers so that you can write unit tests, espresso tests, so UI tests, Dagger, navigation components, everything. It's beautiful. Definitely, this is the best course on the website.